This class wants to look at the internet, intranets and extranets and see how these various types of networks can support business. Let's start by looking at the 6 major roles and goals of information technology. First of all, it increases employee productivity by reducing time and errors and costs. So information technology is a way of speeding up production. It leads to more accuracy and more precision, better communication systems, and many applications that are used in IT greatly facilitate the workflow within businesses. So it leads to better decision making, more precise decision making based on better information, speedier information, more timely information. And also it can lead to improved team collaboration. The team don't have to be physically in the same place. They can network, they can use the internet and use the tools for communications that modern IT supply to communicate. They can deal with each other as if they're in the same room, when in fact they may be at different centres or even in different countries. Also, it enables the business to create partnerships and alliances. So the business is able to deal with other companies, strike up arrangements with other companies to help them in achieving their overall business goals, and also to monitor the progress of those relationships, because the internet can lead to transparency. They can see what their partners are doing and what they're saying and how they're operating. So there's much more transparency, if that's allowed, if all the partners to the agreement agree that there should be such transparency. There's a global reach all over the world, taking into consideration cultures of each nation or society. So it's possible that the communications facilities within business can reach right around the world. And the information flows are almost instantaneous. Now, going back 50, 100 years, communications around the world was a very time-consuming activity. Letters had to be sent and go by ship perhaps, and it would take a long time for communications to flow forwards and backwards. Now it's almost instantaneous, so that business is greatly facilitated by the greater reach of the internet and the speed and efficiency of the internet. Organizational transformations, as the organization evolves and responds to an ever-changing marketplace. The company is able to watch the trends that are taking place globally, the trends that are taking place locally in their own country and also globally. They're able to watch the trends emerge and design policies to enable them to capitalize on those trends, to redesign their products, to reposition their products in the marketplace, to alter their marketing strategy, or whatever. They're able to see what is happening and they understand the pulse of the market more directly than in the past. Now the key terms, well, the key terms would be telecommunications. It's the transmission of all forms of communication, including digital data, voice, fax, sound, video, and it's moving from one location to another. It's easy nowadays to teleconference with partners around the world, allowing for time differences, because some people may have to stay up during the night to take the conference call, but allowing for that. The information flows are very direct and very efficient. It's not just two or a small group of people sitting in front of cameras doing the video call, but they may be able to show their ideas regarding a product or propose changes to the product, or they may be able to hold up documents and show what they mean by certain ideas. And so it's much more flexible than it was before. So telecommunications has come a long way. And also networks. This is the idea of a group of computers and peripheral devices connected by a communications channel capable of sharing information and other resources amongst them. Companies may have intranets, may have their own group of computers all connected so they're able to communicate internally. And this keeps all of the day-to-day workings of the business, if you like, it keeps it private within the business. It's an internal group of computers all talking to each other, sending communications from one department to the next, and sending information and documents from one department to the next, and calling meetings and publishing the minutes of meetings and so on. But of course there may be a bridge to the internet as well. It may be that the company operates in different countries and has branches in different countries, and they wish to share the day-to-day documentation and processes in one company with that of one of their branches in a different country. So there may be a bridge to the internet. It may be a private network that they have established with one of their branches overseas. The communications network must carry the data, and the data, the amount of data that's moved is called the bandwidth. It must have sufficient capacity. Video is very expensive in terms of bandwidth. It requires a lot of bandwidth. Conferencing requires a lot of bandwidth. Otherwise the conference will break, the images will freeze, the connections will break down. So there must be some sort of assessment of the amount of capacity that the company has with its branches overseas. If it's going to teleconference, it must ensure that it has enough or sufficient bandwidth to carry the signal. If it's just two people, one in each country, typically they would need about a meg per second speed of transfer, and they must have the capacity of delivering that amount of information. A video typically is around 24 frames a second, which is roughly the same as sending 24 pictures every second, and that gives good quality video. But these statistics change as progress is made with the internet, and over time we require more. We require better connections, and we require more people to be involved in the video call, and it becomes much more complex. But essentially there must be enough space to enable it to happen. Now the internet and the World Wide Web. Well, the internet, for a start, it's a collection of probably billions of computers and networks. It doesn't have a center. These are just these are just computers connected to each other. They're right around the world. So if we know the address of a company in some remote part of wherever, then we can type in the address, and the chances are we'll get information about that company. It may be in a different language, and it may portray different products, ones perhaps we're not that interested in, but nonetheless we can bring up information. So we're really trading here in information, web addresses and communications addresses that the network can bring up. Nobody actually owns the internet. As I said, it really has no center. It's a collection of computers all talking to each other. And if one computer breaks down or comes offline, it reconfigures itself. It finds other ways of sending the messages. The messages may go around several other computers and go to the same person. So the information is constantly flowing. If computers are there, it may flow through them. If the computers are taken offline, then the information will find other ways of flowing to get to its destination. So no one actually owns the internet. It started in about 1969 as a US Department of Defense project. It was called the Advanced Research Project Agency Network, ARPANET. So the Americans kicked it off around 1969. It's subsequently developed by the National Science Foundation Network, NSFNET, in around 1987. And then it became much more formalized. So people knew what was required. They knew that it had to have a backbone. It had to have some sort of agreed set of protocols. Computers must be able to speak to each other. They must understand their language. There was a common language, and the common language would be the backbone of the internet. And the computers must be connected in some way. The best way of connecting the computers would be telephone lines, because telephone lines existed. Tim Berners-Lee, an English guy working at CERN in Switzerland, working on the collider in CERN, was instrumental in developing this idea of a common language, a common protocol, HTTP://. Someone had to come up with that idea, and it was Tim Berners-Lee who introduced this, and that enabled computers to understand that they should talk to each other using this common standard. So the World Wide Web was born, generally known as WWW or the web. And one of the great things about the web is that it has what we call hypermedia. Now hypermedia, as I'll say again in a second, is very similar to a hyperlink. A hyperlink is non-linear. A hyperlink can jump anywhere. It doesn't have to jump to the next computer and from the next computer to the next one. It doesn't move in straight lines. A hyperlink can just jump from one computer to another computer the other side of the world. So it's not linear. It doesn't have to move in straight lines from one computer to the computer next door to the computer next door again, and eventually find its way to the other side of the world. It can actually jump straight from one computer to someplace else, different country, different company, or it could just jump to the next door neighbor's computer and send them an email. Hypermedia is very similar. We can pick up videos from different computers, different parts of the world. We can connect to radio stations and television stations around the world. It's just non-linear. Let's have a digression on this, hypermedia. This is a Wikipedia based set of comments. This is the hypermedia. This is the extension of the term hypertext. A hypertext, if you remember, is just a link that goes from one page to another one. The other page could be, as I said, the other side of the world. It's a non-linear medium of information which includes graphics, audio, video, plain text and hyperlinks. So hypermedia can include any or all of those. This contrasts with the broader term multimedia, which may include non-interactive linear presentations as well as hypermedia. So multimedia tends to be different types of media. It could be text, video, sound and so on. But hypermedia includes graphics, and it's non-linear. It jumps from one place to wherever. So it's slightly different. And finally in our list, we've looked at the backbone, the idea of the backbone, the World Wide Web, hypermedia. We've got hypertext. Hypertext being a link associated with a piece of text. Clicking on the link takes us to a different page. And as I said earlier, that page could be anywhere in the world. It depends on where it's linked to. So how does the internet work? Well, let's have a look at a web page. Here we've got an address, http://www.microsoft.com, etc. On the in the address bar. So that's where it's going. Now that must be translated into computer language. So the computers don't really understand English. They just understand computer talk. Generally speaking, computers run on the basis of notes and ones, what we call a binary code. So that needs to be translated, and that's translated into what's known as an IP address. And IP addresses tend to have, like we've got in the box on the right hand side, we've got an example 1.160.10.240. That could be an IP address. And if we typed in that number, we may find we go to exactly the same page as typing in, let's say, Microsoft.com or Yahoo.com or whatever. So if you've got your own web site, your website will have a name, and there'll be a domain name server that gives it that name. The domain name server connects the IP address, which is what computers understand. The domain name server connects the IP address to a name that we understand, the name of your website, yourwebsite.com or whatever it is. So the domain is made up from top-level domains, which would be .edu, .org, .com, .net, whatever. These are called top-level domains. And so, for example, Microsoft.com, the top-level domain there is .com. And many countries have got their own. For example, in the UK, there is the .co.uk. In America, there isn't. There is .com and .net and so on. The address we've typed in, the Microsoft.com here, as I said, that is made up from an IP address, which has been translated by a domain name server into an address that we can read. That address is known as the URL, the Uniform Resource Locator, the URL. So an address on the internet is known as a URL. So, for example, it identifies particular web pages. The URL for a web page, it could be like we've got here on the very bottom box of this slide. We have an example, http://www.microsoft.com/security/default, etc. So that's the URL for that page. And if we type that into the browser, we will find that page if it exists. The http://www, that goes back to the man I mentioned earlier, Tim Berners-Lee, who developed this protocol, this recognition, if you like, and that was his genius, because without that it would be very difficult to find our way around the internet, and computers simply wouldn't know what they were doing. So once the computer sees HTTP, the hypertext language, it knows this is a web page. It's looking for a web page, and then it goes on to look for the particular URL. And of course that URL has got an IP address somewhere lurking in the background, which the domain name server will connect up for us. So that's essentially how the naming convention on the internet works. Now, the hypertext markup language is one of the languages that's commonly used when designing web pages. There are additions to this. There's XML, and there are all sorts of other conventions that can be used. We can use JavaScript and so on. But HTML seems to be the foundation, and certainly was the starting point of the internet. So it's worth just looking very quickly and very basically at the structure of HTML. So it's the hypertext markup language, HTML. And it's the language that's used to create web pages. Now, it looks quite complicated. So the structure of HTML would start with, first of all, you need to tell the computer that it is HTML. So what normally happens is it goes inside brackets. So we see the first line of code there is HTML inside of two brackets. Then the page must have some sort of structure, and we start with the head. The head of the page is the page's description. It must tell the computer what this page is about, the name of the page. And we close the head. We've opened the head, we've opened this part of the language. Now we must tell the computer we finished that. So we finish it by putting a forward slash. So if you look at the second head, it goes bracket forward slash head bracket. In other words, we finished with the head. Now we start the body of the text. So we go to the main body of the text. What is this page about? What information's on the page? What graphics are on the page? What videos are embedded on the page? How is the page designed? So we have the body. So we open a new tag called body. We have brackets on either side, and we have body. We enter the content of the page, and then we close the body again. We have a bracket forward slash body bracket. We've closed it off. And when we finish the whole thing, we want to tell the computer we finished. We finished this particular page. We started at the top with HTML inside brackets. At the very bottom, we must close it. We must say bracket forward slash HTML bracket. In other words, we finished. The forward slash tells the computer this is finished now. And that's, in a very simplistic way, that is the nature of HTML code as used on the internet. So, types of internet connections that we may have. Well, we may have symmetric, SDSL. Symmetric means the connections are equal in both directions, going out and coming in. We could have 1.5 megabits per second, or we could have 2 megabits per second, or half a megabit per second, whatever, but it's equal. Going out, uploading to a server outside of the organization goes at one speed, and coming back from the server comes back at the same speed. That's called symmetric. Or it could be asymmetric, ADSL. In this case, the upstream sending information out could be at one speed and coming down at a different speed. Generally speaking, sending information out is slower than receiving it. That is typically the situation. But asymmetric, ADSL, means going out at one speed and coming back at a different speed. In the example I've got here, we, let's say, upload to a server at 3.5 megabits per second. And we download from the same server at 24 megabits per second. We've also got something called very high speed connections. Very high speed. The downstream and the upstream transmission rates can be very high. We consider 100 megabits per second to be quite high, but in many parts of the world they receive data and send data at gigabits per second. I think South Korea has got a very fast connection, and many parts of Japan. And there is a movement all the time to increase the speeds. There's a lot of research going into increasing the speeds, and increasing the speeds in mobile devices as well, in smartphones and so on, so that videos arrive at incredibly fast speeds, gigabits per second. So when we talk about speeds here, it's just to illustrate. Very high speed in a year's time or in 2 years' time will be a lot different from what it is today. There's also something called T1 and T3 lines. These are equivalent of 24 conventional telephone lines. Again, the technology is moving on all the time, and fiber optics and the use of fiber optics through buildings makes internal networks very, very fast. And there is an increasing use of fiber optics bridging out into the internet. And the movement is on in many countries to try and improve the speed of their internets, because it's such an important commercial tool. Governments are investing in it, companies are investing in it, try to improve the speed and the connectivity of the internet. So when we talk about T1 and T3, these are quite famous examples, but by and large the world moves on, and there will be new technologies in the future which will supersede these. Navigational tools, search engines and directories. Well, navigational tools would be graphical web browsers. There was a time when perhaps the computer was a dark screen with a little cursor flashing, and people had to type in long bits of code to try and find something. Now, graphical users and GUI, graphical user interface, enables us to more conveniently find what we're looking for. So navigation tools have become easier. Plus, there's a greater use of hyperlinks, which means the user just simply clicks on a link and it goes automatically to that particular page. There are various search engines of great importance to us, because the search engines are very sophisticated tools of the internet, which enables us to do very sophisticated searches and very refined searches. Probably the most famous of which nowadays would be Google. But there are others, and Yahoo has got one, and Bing has got one, and so there are many other search engines that are available. Also, some sites may be directories in themselves, a bit like old-fashioned portal sites, where they collect a lot of links on a particular topic, a particular theme, and people go to that particular site because that site has done all the work by collecting all the various links and offers brief discussions of what the sites are about, and it saves time. So there are directories and, if you like, portal sites. It's an old-fashioned term, but they're still around to some extent, and you do find them. Yahoo is probably a very good example of a successful one. And I think that's all we need to do in this context. So let's leave this topic and round it off and say thank you very much for watching.